chemistry students, here we are again with another section in our unit on matter. We're going to talk about mixtures today. So you probably have a good idea of what a mixture is, but to give you a definition, a mixture just has variable composition. It's not uniform throughout, it varies. So I gave a little example of a mixture of air. This shows gases in clean air, and we have a lot of different things here. It's a mixture, obviously, because it has variable composition. We have some compounds. Here's methane with a carbon and 4 hydrogens. We have carbon dioxide. We also have some diatomic molecules with the elements of oxygen and nitrogen. We have some individual atoms floating about: helium, argon, neon, krypton, xenon, a whole bunch of different things going on in the air. So this is definitely a mixture. It's also important to note that the composition of the compounds themselves here remain the same. We have carbon dioxide. If you find another carbon dioxide molecule somewhere, it will still be a carbon with the 2 oxygens. Same with the methane. It will have the same composition with carbon and then the 4 hydrogens. So those compositions stay the same even though there is variable composition throughout the air mixture. Here's a quick review. You've seen this slide before, but we're going to add something. We're going to add mixtures to it. So here we have our elements. We can have them in the form of atoms or in the form of molecules when they're diatomic molecules. Here we have our compounds. They are molecules with 2 or more different atoms in them. How does that look when we talk about mixtures now? Well, here we have different atoms in this mixture. It is a variable composition within that space. Here we have another mixture. There's some atoms and there are also some diatomic molecules. Here we have a mixture of different kinds of diatomic molecules. The pink ones represent one kind of element, and these little purple ones represent a different kind of element. Here we have a mixture that has some of the diatomic molecules and some compounds. That's a different mixture. Here are some more examples of mixtures on a macroscopic scale, some of them. We have this sand that you can see obviously has variable composition. All these candies, huge variable composition there. Tap water, I just wanted to mention, is a mixture because unless you've purified the water, there will be some salts and some minerals in your water, and so it is not pure H2O. There are some other things in there. So tap water is also a mixture. Now, what is this? Alloys. Alloys are a special kind of mixture. They are a mixture of metals. And we talk about alloys when we mix different metals together. You may be familiar with some of the naming of types of gold or pureness of gold. 24 karat gold is pure gold. Okay, that's nothing but gold in there. If you start talking about 18 karat gold, or even 14 karat gold, those are actually alloys. They are mixtures of gold, copper, and silver together. 14 karat gold has more of the copper and silver in it than even the 18 karat gold, but those are alloys when you hear those terms. So let's talk about a couple of different kinds of mixtures. We have homogeneous mixtures, or homogeneous mixtures. You can say it either way, it doesn't matter. And you're probably familiar with the prefix homo. It means the same. So a homogeneous mixture is the same throughout. You might have heard it referred to milk, homogenized milk, because they have processed the milk in such a way that the fat and the milk do not separate from each other. They remain homogeneous throughout. So we call these solutions. And here's an example. You take a little bit of Kool-Aid or sugar and flavor and color and put it in some water and mix it up. You get a nice solution that Although there is variable composition when you look at it very close, there's variable composition within that solution. It is fairly much the same throughout. There are not large regions where there are big clumps of the Kool-Aid or the sugar, and then other regions where it's just water. Hopefully you've mixed it a little better than that, and you get a nice homogeneous solution, a homogeneous mixture. Different from that would be the heterogeneous mixture. So that would be where your mixture contains regions with different properties from other regions. This ice water is an example of that. The places where the ice exists is very different from the places where it's just water. So this is a heterogeneous mixture. Likewise, if you did have a big clump of Kool-Aid stuck to the bottom of your glass, that would turn into a more heterogeneous mixture rather than a homogeneous mixture. So pure substances, also just to note, are exactly what they sound like, pure. They always have the same composition. So elements, compounds can be pure substances. We can have a pure substance full of elements here. We could have a pure substance full of diatomic elements. These are just some representations of pure substances. We could have a pure substance where it's made up of just compounds. This, however, is not a pure substance. That is a mixture. And you can see it is a homogeneous mixture. There are not big regions where there are very different properties than other regions. Quick review. When talking about matter, we can have pure substances or we can have mixtures. And you remember, a pure substance is only one kind of substance. A mixture has varied composition, various substances in it. So pure substances, if we look at those, we can have elements where we have just one kind of atom. This could also include diatomic elements. We could have diatomic oxygen, for example, throughout this, and that would also be a pure substance. Here is a compound. Compounds can be pure substances. If you just have one kind of compound throughout, it will be a pure substance. A mixture is when there are various kinds of substances involved. So we can have homogeneous mixtures, and here's an example of a homogeneous mixture. It's obviously a mixture. We have different substances involved, but there are not large regions of varying composition in it. A heterogeneous mixture, does have this differentiation where we have a very different region right here than right here. So it's heterogeneous because it's not similar throughout, and those are mixtures. Now, if you would like to work for an advanced proficiency, I'll ask you to get really creative and come up with some great questions and see what you can do to go above and beyond. So, see you in class. Thanks.